We are at 2 o'clock and we're ready for the next and final presentation of the day here. Next up we have Eric Eager from Pro Football Focus, and he's going to be presenting his paper called Using Tracking Data and Charting Data to Better Evaluate NFL Players. So welcome, Eric.
Okay, well, thank you all for coming. The first 6 talks, I felt like going last might have been fun, but then the first 6 talks are really humbling. So great job to everybody before me. As they said, I'm here talking about the NFL. I think this is a really cool situation. I believe this is the first year for Sloan that American football had its own designation, which I think is a fun watershed moment for us as a community. Want to thank my co-authors, Tej Seth, who is here actually, is one of them as well, and obviously for you guys, for all of you for staying the entire time here. I kind of want to talk about the general state of football analytics, right? One of the reasons I wanted to write this paper, give this talk, was I think there's been so much progress in football over the past 5 to 10 years. I mean, it used to be, Brian's here, but it used to be Brian Burke basically writing about football, and all of us nerds in high school and college reading about it. And it's actually, grown from that, in the last, few years due to, a few different sources of data. And my talk today, I want to talk about how oftentimes we use these independently, and we get great results. We get great insights about the game, but we could do better by using them collectively, and we can use them to enhance one another. And just a few examples of these things. So play-by-play data, we owe a great debt, I think, to Ron Yurko, Maxime Horowitz, and Ventura at Carnegie Mellon for building NFL Scraper, Ben Baldwin and Sebastian Carl for NFL FastR. It makes my job as somebody who hires data scientists to work for a football analytics company a lot easier, because I can almost see their work before they even apply for a job. And then there's charting data. So I work at PFF. People who aren't familiar, we by hand go through and chart every single NFL and every single college football game. We have the player grades in addition to a bunch of different sort of labels and event data. Sports Info Solutions does something similar. There are other companies that do some similar stuff as well. And then, about 5 years ago, the NFL with, who now sort of proliferated by Michael Lopez and his group, has given us charting data using RFID chips in the shoulder pads and the ball. And this has given us a lot of great insights. I think of, just right now, like expected points was something that only a handful of people really knew all that much about until, 5 or 6 years ago. And now, you can't, swing a cat on Twitter without hitting an expected points graph. And you have win probability as well. We're far more capable of contextualizing the game because of these advancements. ESPN, has taken tracking data and making things like pass block win rate, run block win rate. These things are on ESPN now. They're on, Sports Center and things like that. You have rushing yards over expected, which was a big data bowl insight that made its way onto the NFC Championship game in the January of 2021. And then PFF, and again, this is a paper that I published at this conference a couple of years ago. We've come up with things like WAR, wins above replacement for football. So there's tons of great in achievements that are sort of individual to the different data sources. And my hope is that we can actually bring those things together and make better insights and evaluate players better based upon all the sources combined. This is just an example of how we've integrated things at PFF. So this is one of the tools that if you are one of our team clients, you have access to. But this is a little bit where you look at the tracking data, which is the dots, which is available through RFID chips, but you also have things like a player's position. That's something that people are going through and charting by hand. And again, this is just the tip of the iceberg as far as what the data availability is. But I want to sort of look at 3 different phases of play here, and showing how we can enhance our understanding by using tracking and charting data together. The first one's pass rushing, so going after the quarterback when he passes. play action awareness, and wide receiver deep speed. So here's the first of these. This is TJ Watt, who led the NFL in sacks this year. So here's kind of an idea of what kind of data you're working with if you have both tracking data and event data, charting data. We track pressures at PFF, so essentially if a guy moves the quarterback off of his spot when he's throwing or gets a sack, sacks are pressures, we'll chart that as a pressure. But we also have what we also chart by hand, win rate data. Essentially, did you win this particular rep? Those two are correlated, but you can obviously win a pass rush rep without getting a pressure if the quarterback gets the ball out quickly. And you can get a pressure without having beaten the person in front of you. If the quarterback is forced by a different defender to rush into you, for example, that's an example of a pressure without a win. And we have sack data, and sacks an official statistic for the NFL. We would like to predict that, right? Because sacks take about 2 points on average away from an offense, which is substantial in football. And then we have things like play level data, so contextual data like down and distance, how many yards there are to go, whether there was play action on a play, whether the game was in field turf or grass, things like that. And then we have XY tracking data. And so essentially what we wanted to do here is build a pressure statistic where our charting data was the training data for whatever insights we were going to glean from tracking data. So we built two models, one for pressure, one for win rate, just to sort of make sure that they both kind of they should be basically the same given how correlated those two things are. And then we had the pressure as a classification and had play level data as well as how fast the defender got off the ball in the first second of the play, both in the Y direction, but also in the Euclidean sense as well. And so here's an example of sort of how important those are. So your Y speed, so the vertical distance that you traverse in the first second of a play, is the most important variable as to whether or not you're going to get a pressure. And this is using an XG Boost model. 2 talks ago, there were talks about decision trees. Basically, it's an ensemble of those. And then you have you have speed there as well. But you also have where the player is positioned at the snap. So X snap and Y snap are basically where they are when the ball's snapped. But then interestingly, some of our charting variables also make it there as well. So for example, nose tackle is whether you're lined up over the center or not. ED is edge defender, so that's whether you're lined up over a tackle. There's a little bit of information encoded in there basically as what type of player you are as well. So that's going to be what we're working with there. And so again, for every play, not only do you get a 0-1 variable for whether or not you got pressure on a quarterback, but you get a probability basically how likely you were to get pressure on a quarterback given how fast you were off the ball and accounting for things pre-snap. And so what's really cool about this, I just want to look at the first table here, but essentially what we're trying to do is predict sacks. And it's the famous sort of process over results idea. Pressure is the process that elicits sacks. And so if pressure rates can predict sack rates better, that sack rates do, then we have something there. And in fact, sack rates with themselves are about basically, I think it's like 0.24 or something, so you just get a little bit better than that with PFF pressure rates, which is the leftmost number. Those are R squared values. The middle number is actually this expected pressure rate, which you get from tracking data. And then adding them together actually gives you more predictive power than either one does individually. And that's actually true about just plain old pressure rate as well. If you want to predict a player's pressure rate, so something that we chart at PFF, the tracking data actually supplements and adds predictive power there as well. Additionally, one of the things that you get for free out of this, I just got back from the scouting combine in Indianapolis. Lots of ink expelled over what people were running in the 40-yard dash. I always found it a little bit silly that we're taking one measurement of a player's athleticism and then using that forever as his evaluation. Here, notice on the right-hand side, expected pressure rate, which is measuring a player's athleticism, tracks pretty well with all measures of his athleticism that he will have done in Indianapolis or his pro day. Okay, so that, and to the left-hand side is our data, so our charting data, which correlates less strongly. So again, you can have sort of a time-varying athleticism measure for a player as a pass rusher by combining these two data sets. And this is sort of the same graph here. If you look at the y-axis, that's expected pressure rate, so that's how fast they are getting off the ball. As you can imagine, the slower you are, the worse you are at doing that. And then the lighter dots mean you jump higher, means you're more explosive, and that sort of correlates with how good you are in getting expected pressure. And then your 3-cone time is a time, again, where it's an agility drill. So these are sort of 3 independent measurements of, not independent, but relatively independent measures of athleticism. And they all track with this on-field measure of sort of football functional athleticism. The next one I want to look at is another trait. So we at PFF, we grade how good players are in coverage. So we'll give them a positive grade or a negative grade based upon whether or not they did what we inferred to be their assignment on a play. And coverage has always been this variable that has been pretty unstable. So great players in coverage don't always repeat that year to year. And so I wanted to uncover from this some traits. And the biggest trait here is basically the tracking data. How far do you bite on play action? So this is an example of what I'm talking about here. Essentially, those 2 linebackers in the middle of the field, right around the 27-yard line, that's Bobby Okereke and Darius Leonard. They're vacating the middle of the football field because of a fake handoff to Derrick Henry. Middle of the football field is the most valuable place to throw the ball, especially 10 to 15 yards downfield. And so if you can get linebackers to move out of that area, you can be successful as an offense. If you can avoid biting on those fakes, then you can be a more effective defender. And so essentially what we did is say, take their Y displacement on a play, adjust that for situation. Situation's kind of fun. It's like, how often do they run inside zone? How often do they run outside zone? What down and distance it is. So on 3rd and 15, there's less of a credible threat of the run, so players don't bite during those plays, but on 1st and 10, they do. And then we sort of average that over time. And what we get is actually a trait where not only does it pass the smell test, Fred Warner just signed the most lucrative contract in the history of linebackers. Luke Kuechly is a Hall of Fame player, and there's a few other players who will probably make at least their franchise's Hall of Fame. But you also get a metric that's more predictive year to year than our coverage grades. And in fact, if you use R² as a measurement, it's about 3 or 4 times more predictive year to year than our coverage grade. So again, using something that we have to try to enhance something that we have as far as PFF is concerned, using the tracking data in this case is pretty successful. So that's just, and I'm calling it BDU, so bite distance under expected is kind of what I'm using. So better bite distances under expected go up, and worse ones go down. Lastly, I wanted to look at wide receiver deep speed. And this is one where I think we're close here in the public sphere, and I really appreciate some of the talks that we've had, the one especially where, sort of this media, how are we educating the fans? I think as we sort of educate the fans here, you see in the Senior Bowl, you see at other events, sort of miles per hour measurements for players. I wanted to contextualize that based upon our PFF receiving grade. So essentially, can you use your speed to get a good grade from us? And a good grade from us sort of translating into, running under a football, catching it in stride, and scoring. A bad grade would be something like dropping the ball or misjudging it or something like that. Again, a failed application of your speed. And so when we built a model here, I'm running out of time a little bit, but we have different speed measurements, so your mean, median, and max speed over the play. That is the most important variable in terms of determining whether a player will get a positive PFF grade on an 8 or 9 route, which is a go route or a corner, so 2 routes that are basically vertical. But there are a number of other factors that influence that grade as well. So as we apply this model, essentially what you get from it is a different grade from PFF that has this stuff encoded into it. And that different grade from PFF does a few things. A, it's more correlated year to year with itself than our grades on deep passes. It's also correlated, as you'll see in the bottom left there, with the 40-yard dash. So players who do this on the field well, generally speaking, do it in Indianapolis, but there's enough noise there to sort of find examples where a player was unable to translate his off-the-field speed to on-the-field functional speed. And so the upper left there, Jarvis Landry's been a good receiver in the NFL since 2014. His 40-yard dash in Indianapolis was quite slow, but he ended up being a pretty good receiver in the NFL due to this. and then Cooper Kupp. And I wrote this paper, I promise, before the Super Bowl. But over the years, he has been much faster than his 4.62 40-yard dash at the, I think it's Pro Day in 2017. So that's, again, another example of somebody who on-field functional speed much better than what he's timed at. And again, a time-varying representation of how athletic a player is versus the snapshot that we're getting this week in Indianapolis. And so to conclude, play-by-play and charting, play-by-play charting data have led us to significant progress. Tracking data, I think, has a lot of promise. I don't necessarily know if we're going to achieve that promise without using those two data sources together. But if we can, I think, and I think it's just limited by our imagination, I think that we can make a ton of progress using these data sources together. And I just want to thank Aisha Dubem for organizing and all the emails and keeping me, who's kind of a klutz, up to speed on stuff, and then my bosses at PFF.
So we're going to go last with Brian on this one, but a couple of questions. So I really like this. First of all, very nice presentation, very interesting stuff. And I agree. I love this combination of taking the tracking data with event data and play-by-play and putting it all together. One of the things that I think is would be interesting by doing that is I'm an economist, so I always think about equilibrium effects, right? So one of the things that I think you can do with the tracking data, in addition to the things that you're combining it with, is look at sort of the indirect effects. So for instance, take the pressure, for instance. You can also quantify the impact of that pressure on tiring out the offensive linemen, on whether it changes the offensive blocking scheme, whether it changes the play calling even from the offense and what they have to do. And I think that's kind of in my mind, that would be the next generation of interesting stats that we can come up with based on this kind of. So I don't know if you've looked at any of that yet.
Yeah, absolutely. I think that the interesting thing with football, which is, football is an extremely column-rich and row-poor data set, and tracking data has at least given us a lot of rows again. The crazy thing, though, is football changes so drastically, right? So I do agree with you. I think the interesting part, and I don't know if it ends up being a small data problem or not, but looking at so play action's a big one, right? So play action like 4 years ago was something that like teams thought was cheap to run. Like, oh, if I need to run play action, that means my offense isn't good enough to throw normally. And then over the course of like 4 or 5 years, we've seen tons of play action. We've seen tons of efficiency gains off of it. And I agree. I think like sort of looking at the second order effects of things would be truly, and also just looking at expectations for things. So like the one thing you could do with the pressure data is literally just say, are we running plays where we're more likely to have pressure on our quarterback just by virtue of the features that we're imbuing on the offense, right? Like to me, I think that's, or are you a defensive lineman? Are you making the expected pressure rates higher by your existence type of thing? And so those are all like kind of second order questions that are not even like the player evaluation questions, but more just football team evaluations that I think are interesting.
Right. And then the other question I had was a more general question. So it's something I would ask Brian as well, which is the objective function is like to take your statistic about linebackers and going for being faked out, leaving the middle open because they're faked out by the handoff. I guess my question is that the right objective function? That's really more about the mean rather than the variance. I mean, it may be a good thing if someone's overly aggressive because what you want to prevent is you're willing to give up maybe more 10, 15-yard plays, but avoid the big disaster that's. And I don't know that analytics has really gotten into that, right? We've been so focused on the mean effects.
Yeah, so one thing I'm looking at currently is the flip side of that. So there's always trade-offs to things. So if you're really good at scraping down the line of scrimmage and stopping runs for no gain, you might be willing as a defense to give up some plays in the middle of the field, as you said, because a linebacker, like I think Neville Hewitt's the top guy on that list. Like Neville Hewitt's not a great linebacker, and especially not really necessarily against the run sometimes. So maybe he is just passive, and that could be what we're objecting there. And to me, I think it sort of has to compare with this sort of what you're giving up to do that. So if you're being a weaker run defense because of that, is that worth it for a defense? My personal opinion is yes, you should. But But even then, like, if you're so bad against the run, because you deploy this defense that grades really well in this metric, then there are costs to that, yeah.
And maybe that's a better way of putting it, is just using these analytics to document those trade-offs and quantify them. Yeah, thanks.
So I knew Brian was on this panel or this judging panel, so I didn't do as much background research, but I had one specific question. I think it was on the bottom of page 11, top of 12. Just wondering about those rankings. Did they better align with popular opinion? Brown, Hill, Jones near the top after using the tracking data adjusted grades? Or were they also well aligned with the general PFF grades?
Can you remind me what that page is, what the top names were?
Like Brown, Hill, Jones, I think were near the top.
So the wide receiver ones.
Yeah, I'm just curious.
Well, like Tyreek Hill is considered one of the fastest players in the game. Antonio Brown's an interesting one, right? So Antonio Brown was a player who was a 6th-round pick in the NFL. He was from one of the MAC schools in Michigan, ran poorly at the combine, which there could be a number of reasons for that. Like players who are not going to be highly drafted oftentimes don't have the resources to pay trainers to optimize their tests and things like that. But then, he became, his personal transgressions are noted, but like on the field, he was one of the best wide receivers to ever play over a course of 10 years. So he's certainly playing fast. And I actually thought when I developed this, I thought Antonio Brown was a great example because I've never thought of him as a fast player, like overly fast, but I always thought he had really good ball control, and that's really kind of or body control when the ball's in the air. And I always thought that kind of what this is doing is saying, can you run in a fast way, but in a controlled way enough to make football plays? And that's kind of, I think, what that's measuring. Tyreek Hill's fast, but also makes football plays. Antonio Brown, I think, is certainly fast enough and is making football plays, better than most players at that speed.
They set this format up like it's a Sloan American Idol. I'm that annoying British guy. What's that guy's name? I'm Simon Cowell. So we could talk forever about this stuff, and we probably have, and we will again. I'll try to be quick. I'll try to ask one question on each of the 3 topics. So on the first, you had a slide where there was a bunch of R-squared values in the first section.
So looking at predicting them from one year to the next. Yeah.
Okay, so that is like a year-to-year
I'm trying to see if I can predict one with the other. Yep.
So, go back one.
Yep.
So the third table with the 40-yard dash. So I just wanted to make sure I wasn't misunderstanding. You're not saying 40-yard dash correlates with the expected pressure rate at those levels. You're saying like when I add 40-yard dash to the model, it improves the R-squared to this?
No, that one's actually a little bit different. So because players only test once, so in some sense that always is going to be, you are always going to be in a predictive framework with that because you test one time in Indianapolis and then all of this data is NFL data. So all of the pressure rate and expected pressure rate comes after what they're doing there. I just took essentially every single player's career averages career pressure rate, career expected pressure rate, and looked at how those correlated to how well they did at the combine. And yeah, go ahead.
For real? Like,
yeah.
40-yard dash? Because that would be like a correlation of like 0.75. Mm-hmm. Like you could predict their expected pressure rate with 40-yard dash alone.
Career pressure rate, yep.
Wow, okay. All right, next topic. Toby touched on it, but one thing I noticed, I have this defensive back model, and I normally test it by like just seeing whether, like if I was doing pass rush win rate, hey, is Aaron Donald number 1? Yeah. Okay, it works. So I'm looking at Jalen Ramsey, and he doesn't show up as like a top guy for at least for this past season. And I'm like, well, nobody's going to buy this, so I'm not going to publish it yet. Right. But then I realized he leaves this cushion that no other cornerback would. And I'm curious if you saw the same thing with these linebackers. Like some linebackers are going to bite harder because they know they can backpedal back to their spots.
Yeah. So I did not show, I generally try to be positive. I didn't show like the worst players in this metric, but the worst players in this metric, like Zach Cunningham is like cut in the middle of the season. Like he is like you watch them over and over and over again, and he's a terrific run defender, but that defense cannot stop anybody. And I always thought it was because he was biting on play action all the time. But to your question, so Devin White's the interesting one for me because Levante David, who plays next to him, who's I think considered a better player, doesn't do well in this metric. So there could be something of like essentially one guy's a biter and the other guy is the retreater on play action plays. And so maybe you're not necessarily looking at this at the team level could be instructive. Sort of looking at the average bite distance of the two inside linebackers, and that's kind of how most defenses are. They both play over the guard. If one guy is designated the player that rushes towards the line of scrimmage because his counterpart is a guy who can cover that part of the field really well, no matter what. That's something I think to the question about second order effects. If you are a linebacker that can do that, then you might be valuable just because your other player can sort of what I would consider by this metric dump value.
Okay. Still have time. Well, okay, one last question. In the importance plot on the wide receiver model, there's like pretty solid levels of importance on things like yards to go and time to throw and things like that. And I would think that, so if I understand, this model's trying to predict the grade on the play.
Like how well they do.
So this is kind of off topic, and I apologize, but wouldn't you want those to be like zero? You would want your grades to be agnostic to kind of that context.
You bring up a very good point. So this is why I haven't even added to this, but like we try at PFF to make our charting data like we don't try to have our charters or our graders do the math and like do the little regressions in their head and like make sure that it happens to be mean zero all the time. So in some sense, like part of what this is doing that, right? It's regressing because our grades are pretty like, and this is a classification. It's -2, -1.5, increments of 0.5. And so essentially what we don't want to do as a football person who's got tons of skills in one direction, we don't want them to have to think about, oh, is this a 1.73 versus a 2? Like we just have them sort of have the discretizations and that's what I threw in here in a classification. So like that's why down and distance and all that stuff is sort of more, it matters a little bit because it's sort of refining some of the discretization of the grading. Well, thank you all for coming. This is a lot of fun. I really appreciate it.